ZeroBuild Summit programımız tüm hızıyla devam ediyor. Gün içinde yapı fuarının söyleşilerine devam ettiğini duyurmuştuk. Bu oturumumuzun ardından sağ tarafımızda yer alan yapı sahnesinde saat 16'da Trans Architecture Swedenbow'da ödüllü mimar Birem Ersin Otonom Değişimler, Yapılı Çevreyi Dönüştürmek ve Yeniden Yorumlamak konulu konferansını dinleyebilirsiniz. Saat 17'de ise Altın Mıknatıs Stand Tasarım Ödülleri yine yapı sahnesinde sahiplerini bulacak. Bu etkinliklere de davetlisiniz. Sıradaki oturumumuzun konusu yeşil binalar. Türkiye'de yeşil bina örneklerinin giderek arttığını görüyoruz. Peki yeşil bina sertifika sistemleri sıfır enerji binalara dönüşümde nasıl bir rol oynayabilir? Sıradaki oturumumuzda bu sorunun cevabını dinleyeceğiz. Ben lafı uzatmadan yeşil bina sertifikasyon sistemlerinin ZeroBuild'e etkisi ve katkısı oturumunu yönetmek üzere sözü ZeroBuild Institute İcra Direktörü Sayın Doçent Doktor Ümit Ünver'e bırakıyorum.
Thank you very much. Dear audience, welcome on board. Thank you for everything, coming, attending to our meeting. In this session, we are going to listen very valuable professors and Mrs. Gonca YILMAZ. The session will be about green buildings, and we are going to hear about the energy efficiency in buildings experiences from Professor Sandro and Professor Agis M.PAPADOPOULOS. And I'm going to give the first name to Gonca YILMAZ. She is an architect. Let me introduce her first. She is an adjunct faculty member in MFA University for High Performance Green Buildings and Sustainable and Healthy Buildings since 2018. She has been working in award-winning projects since her graduations from Pratt Institute in 2003. With TPG Architecture, Tabanlı Yollu Architects, since 2014, she has been practicing architecture, green building consultancy, and Biophilic Design in her own design office, LI Mimarlık in Turkey, and co-partnering with Design Republic New York office for projects worldwide. In 2008, she became USGBS's lead AP BD+C, specializing in leadership in energy and environmental design, and in 2020, WELL app, a leading tool for advancing healthy and well-being in buildings globally. She is a member of USGBC, TMMOB, CHEDBIC, and CQ. She also has publications in various green building journals. She is going to make her presentation on healthy individuals in healthy places with LEED and WELL certificates. Here is your stage.
Thank you. Hi. I'm going to start to introduce you green buildings from an eye of architecture. And so, since I'm an architect, I'm having the point of view for the green building designs. So as we architects, we always quote Vitruvius, and for us the strength, utility and beauty is very important. But nowadays we are always concerned about the sustainability of the buildings. Actually, we had no green building certifications before Christ. And however, we had Socrates, who was designing green buildings as examples of passive solar housings before, way ages before. So also, I like to give you a couple of examples of other architects. For example, Frank Lloyd Wright. He has been designing since the beginning of 20th century. And he designed until 1960s. and he always referenced nature in his buildings, and also he was always connected with nature. So we can see a quote, study nature, love nature, stay close to nature, it will never fail you. And also he has been designing a lot of buildings referencing and biomimicking nature. And also if we are going to look at Oscar Niemeyer, and he has been designing a lot of the ministry buildings in Brazil. And on the left-hand side, for you guys, same, the Health and Education Ministry, designed in 1936 in Brazil. He was paying attention to thermal comfort, maximizing of daylight, shading, and reducing the heat island effect on the right-hand side in the Itamari Palace, Brazil. And these are the buildings that has no green building certification. But I like to move on why we are having a green building certification. Within the Industrial Revolution, we started to have a lot of materials produced. It was on our beneficial side. However, there was a negative effect on the pollution, waste, a lot of waste, and we are still having problems with the locally sourced materials, which is green building is specializing on, and also we try to have more circular economy instead of the linear economy that Industrial Revolution has brought us. So that's why we started to think we should get sustainable. So, and why we try to be sustainable, we have to protect the nature and the natural resources, and social equity, balanced economy, and create circular economy. So the sustainability, if a project has to be sustainable, it should intersect in the values of environment, economy, and social balance. So that's why we started to think about the green buildings. And why we are trying to build green buildings, because building industry is one of the most important portion of the economy worldwide, and creates a lot of imbalance in environment. So on the screen you can see the green buildings can reduce the energy use by almost up to 50%, the carbon dioxide emissions to 39%, water use to 40%, and solid waste 70%. I'm going to show you an example later on a building that we have designed that we achieve already these amounts. So US building impacts, because the United States makes better researches on this stuff. So 14% of the water use around United States is being used by the buildings, 39% of greenhouse gases produced by the buildings, and 65% waste output, and 76% of electrical consumption is being done by the buildings. So that's why if we are going to reduce all these environmental, economical, and social impacts, then we can make an achievement. That's why the green buildings has been started to design. And the green building certifications around the world, there are a lot of certifications, but I'm experienced in LEED&WELL certifications. But there are Green Star for Australian, Living Building Challenge is also American and very challenging. And BEST is Turkish, and that has been designed for the residential buildings in Turkey. And EDGE is designed by International Finance Conference. But I'm going to introduce you the LEED certification. And why we are trying to get the certification, because if we are going to make any consumptions, and if we can measure the impacts, we cannot manage it. That's why we are trying to get the certification and see how our buildings' performance are being done. So LEED consists of location and transportation. So when we are within the building, we like to have the protection of the land and access the public transportation and green vehicles. Sustainable sites in order to have sufficient green open space and light pollution reduced. Also been designed in a correct site. And energy and atmosphere for the optimizing sustainable energy production and metering. And water efficiency to reduce the water consumption. And indoor environmental quality and material and resources, they also intersect with the healthy buildings as well. So we try to keep the buildings in natural and efficient environments. And also we try to reduce the effects of the construction waste management, and we try to use clean materials. So this is how LEED certification works. So I just want to introduce, if you are going to get LEED certification, that happens with the prerequisites and also credits that you have to achieve. The prerequisites are the stuff that you have to accomplish, and the credit sections are being done by the optional. So, but you have to have at least 40 credits in order to get a LEED certification. And if you are going to get over 80 credits, so you are going to have one of the smartest buildings in the world. So, and the system goals of LEED certification is to reduce contribution to climate change, enhance individual human health, protect and resource water resources, protect and enhance biodiversity and ecosystem services, promote sustainable and regenerative material cycles, and build a green economy and enhance community quality of life. So if we are going to achieve with the LEED certification, then we are going to have a sustainable and a better lived world. So as I just mentioned before, these are the credits categories. And we can achieve any type of building. So if it's going to be a building design and construction, we can either get credits, a certification for new building or an existing building as well. Also, interior design projects can be certified as well. And what is challenging is the new neighborhood development. I hope to see that in Turkey more. There are no neighborhood development projects in Turkey yet. Hopefully, we are going to have that. I'm going to show you some examples of the LEED certified buildings. So these are new construction and major renovations of an airport and the Hearst Tower. Hearst Tower is one of the oldest LEED certified buildings. And after 2006, they achieved better conditions and they recertified the building in a better manner. And even a museum can be certified, or for example, a coffee shop like Starbucks all around the world are LEED certified. So they are healthy and sustainable at the same time around worldwide. I haven't seen in Turkey yet, but they are going to probably become LEED certified. And this is one of the projects that I have done. So this building has been designed in a way that is already on a sustainable site. So the location of the building is in the city, so they are very accessible with the public transportation, all bus, ferry, or subway. They have the bicycle storage and access to bicycles. Also, the reduced indoor environmental quality is also very high. Actually, this building is 65% of energy efficient with, because of the all exterior design. the way it has been designed, and also the way of the mechanical systems are working, the shading as well. So, and also they are 40% water efficient. So we used a lot of smart technologies in this building. And even though it's located in Izmir, its climate condition is in a natural way, so you can have the circulation. Also, the materials has been used wisely, and locally sourced materials has been used. And you can see on the shading that it's already shading. Building is automated. If they are going to get any type of sunlight, the shades goes automatically and creates a better environment. So this is a very smart building. And you can see the scorecard of the building. So we had the construction activity pollution prevention and all the development density and community connectivity with full credits. It's been 70 credits as a total, and achieved gold certification. Actually, the target was silver, but then we achieved the gold. And social environment affects the most. So that's why we are trying to improve our indoor spaces. And it's a circular way, and as I said, they can coordinate well. And I'm just passing a little quickly. And WELL certification, same as LEED certification. It's concerned about air, water, nourishment, light, movement, thermal comfort, sound, materials, mind, and community. I'm going to go very fast. And they are all interconnected to each other. So we try to keep the building's air conditions in well. So we try to have the natural climate controls. And we try to reduce the impacts of the bad environmental indoor effects. And we here, instead of the water efficiency, we are concerned about the quality of the water that is being used in the building. So the cleanness of the water. And if we can get reached to the clean water within the building. And also we concerned about the nourishment, because it's very important for the health as well. And the stuff that's been reduced within the building. From the architectural point of view, the light, and that also coordinately goes with the LEED certification, same as with the occupant controls. As you can see, I think my time is up, and I just go a couple of my slides, and the movement. And we introduced a way of new working methods, and the thermal comfort, and the sound management as well, and the materials, clean materials. And from the biophilic point of view, we try to keep the nature within our buildings. And we try to use the natural analogs, and we try to imitate the nature as much as possible. So, and these are the stuff that we design for the natural and healthy buildings. So it's always concerned and focused on the people and how we live. So thank you very much.
Thank you very much, High Architect Gonca YILMAZ, for this very valuable and informing presentation. And the next presentation is going to go to Sandro NİŽETİÇ. Professor Sandro NİŽETİÇ is full professor at Faculty of Electrical Engineering, Mechanical Engineering and Naval Architecture at University of Split, Croatia. He is head of the Laboratory for Thermodynamics and Energy Efficiency at Faculty of FESP, University of Split. He has published near 200 research and conference papers as well as techno-economic case studies for industry. And from 2009 to 2013, he was UNDP project coordinator in Croatia on projects related to the implementation of energy efficiency measures in public buildings. He served as a deputy minister in the Ministry of Construction and Spatial Planning in Croatian government, and he was also a vice dean for research at Faculty of FESP. He serves as an associate editor in Journal of Cleaner Production and International Journal of Energy Research, and editor-in-chief of Energy Sources, Part A journal from Tyler and Francis. Here is your stage, Professor Sandro.
Hello to everyone. First of all, I would like to thank Ümit and the overall ZeroBuild team for excellent organization. I'm thrilled and happy that I'm able to share Croatian experience. So now I'm talking about a project that was run a few years ago, and after UNDP had removed from Croatia, later Croatian institution had took over that project, so I can speak about project, and now I can speak what was after overall project duration and what was basically the heritage of this project. Of course, this project was mainly run by UNDP Croatia in collaboration basically with all major Croatian institutions. I don't want to read now and to stress out all of them, but it was a very important project in Croatia. Like each project, when you are trying to run the project, there are always barriers. Barriers can be from political point of view, barriers can be economical, technical and social. Plus, we have also something which is related to cultural mindset. Each people are different, someone accepting changes, someone don't want to accept fast changes. So just a little bit of regarding the general project structure. As I said, project was run by UNDP. First project was funded by Global Environmental Facility. Later funding was taken over by Croatian Fund for Energy Efficiency and Environmental Protection. Between this project we had two major projects. First project was sustainable energy management in cities and counties, and the second project was basically the same as the first one, but since Croatian public buildings are divided regarding the funding, so cities and houses and the counties has got separate funding than those objects which were funded mainly by government, and because of that, because of nature of funding, we needed to divide it on two different projects, but activities were completely the same. Just quick about Croatia. So Croatia is a small country, just 4 million, but we have a lot of counties, which is of course creating a problem when you want to run some projects. It would be much more easier than that Croatia is divided on 2 or 3 regions, but you can see from this slide that we have quite a lot of counties, which was very demanding to roll this project, which contained over 11,000 public buildings. So what was basically the main idea, main mission of the project was to remove barriers to energy efficiency of Croatia, and the most important, to create and to establish continuous process regarding energy management in public buildings. So since in Croatia we had around 40% of overall building stock, majority of buildings of course were ones which were directed to residential sector, and around 10% were public building. Since we have noticed that residential sector was quite high, we have later extended our project also to residential sector, and I will discuss a little bit later how we have extended. So what was the meaning of sustainable energy management in public building? That means where we waste energy, how we use energy, which energens we are using on level of each building, and how much of energy and water we are using, and of course what is the cost of overall cost for energy. What is the meaning of continuous process? So for us, when we have started project, the idea was to have people with responsibilities in cities, counties, in governmental buildings, monitoring efficiency procedures, energy consumption indicators. We should define objectives for improvements based on energy indicators. And finally, final goal was establishment of energy efficiency projects in buildings, establishment of examples of good practice. So project was organized on national level, city, county level, and we had also established energy offices in each city in Croatia, in each county of Croatia, and each city had an office which was in charge for each building, which means that all public buildings were covered on the way that each building got one responsible person who was communicating with cities and counties. So first we had the project preparation, then establishment of offices, then very important step was implementation of energy management information system. I will talk a little bit later about it. Then establishment of info points, which was our extension of the project, how we wanted to communicate with residential sector, and finally energy auditing, which was of course key in order to maintain desired number of established projects. House in Order project was the same project, as I said, as sustainable energy management in cities and counties, but it was mainly directed to public buildings, which means hospitals, prisons, ministries, and all other buildings that are not owned directly by cities and counties. If we look the main project steps, first step is of course political responsibility, then development of database, collecting of all necessary data for buildings, and after that start of investment cycle. And very important feature of our project was also education, because without education of people, residential sector, without education of technical staff who should sit in cities and counties, we are not able to run the project. This is example of formal documents. One interesting document was Energy Charter, because it was only document in Croatia where all political parties have signed the same document, because usually you have opposite opinion, and that was very good step for us in order to encourage people to implement this kind of project activities. UNDP has got very important role together with cities and counties. So when we have started our project, we have clearly divided what are the main tasks for UNDP and what are the main tasks for cities and counties. So we have defined all procedures. I will not enter the details because we are running out of the time, but you can see that everything was very well set, and later, after UNDP, some Croatian institution had took over this kind of activity, and project was running also after UNDP. As I said, a very important tool was our energy management information system, which was first database, so very interesting web tool which we have developed that was collecting all necessary data about buildings. So this tool was developed between our project, and we have educated more than 1,500 people how to operate between this web software solution. And as you can see, it was 2012 or 13, still we didn't have in Croatia building energy certificate system, but we have managed to set some energy labeling between this software in order to identify what are the energy what are the building energy performance of specific buildings that were tackled within this project. Education, as I said, was a very important part of our project. We have educated teams in cities, investment departments, building managers, employees, and finally we have educated also residential sector. We have developed special course for energy consultants, so those were people who should sit in cities and counties, who should have base education because they need to have a certain technical knowledge and level in order to be able to understand problematic which is linked with energy efficiency in buildings, as one of the main problem was lack of technical staff which are employed in cities and counties, and which was of course critical feature because without people who don't have minimum technical education we are not able to run the project. We have also developed green office education, which was specially targeted education for people who work in public buildings with a lot of offices. We have also developed special education for young generations, so for school kids. It was school Our Think of Tomorrow, which was very nice, very interactive education because it is very important that from the young we are educating our kids what future should bring. And on this slide you can see former Croatian President Josipovic, he was supporting also our project. This is an example of billboard which was set on streets all over the Croatia to encourage public sector, or to encourage residential sector to implement energy efficiency measures. Those are examples of special designed targeted materials for residential sector if you would like to have base education about thermal insulation, lighting and whatever. And it was very simple and very clear because it was produced for residential sector. Then we have also established EE corners. This is example of energy efficiency corner in Zagreb and also energy efficiency corner in Split, where we have put all major technologies. When one educated person was there, they have operating time, and then people can come and ask, see special designed products, and they were able to get base knowledge, and they were able to be encouraged to implement energy efficiency measures in buildings. We also had our website, which was 24 hours a day, open, active, with also free info telephone, where you will be able to ask everything which is linked with energy efficiency of buildings. So what were the main results? The main results were in Croatia that we have managed to enroll in this project over 100 cities, 20 counties. We have managed to establish 100 energy offices with people. Over 8,500 buildings were included in energy management information system. More than 13,000 educated users in different educated programs. Over 1,000 energy audits were performed during our project. And if you can see also some financial funds, this project was positive from economic point of view, when we'll see achieved energy savings and also overall project budget in 7 years of project. For me, the most important thing is a generation of young professionals. We have created over 120 young professionals who are now sitting in different public institutions. But they are highly educated, they have project experience. And our project was also, after UNDP has finalized activities, was taken over by Croatian Fund for Energy Efficiency and Environmental Protection. And now we have basically structure what we have developed between the project. And we were also example of good practice for all other neighbor countries in the region. And we have very good experiences because other countries would like also to apply our project, our experience. So, what is my field experience? My field experience after it was almost 7 years, 6.5 years of project experience. Of course, you have project idea, you have problem with legislation, you have problem with political awareness. Sometimes it was very hard for me to convince, especially local politicians, to do something. Then you have problem with lack of educated professionals. In the cities and counties, we don't have people who are educated. So how we can run something which is some project which has got very technical nature or technical background. Then funds and financing. Sometimes there is a problem, but now it is not a problem if you have a good project. It is not a problem to find the money if you have a good project. Finally, in Croatia, the big problem was administration, a lot of paperwork, which was, of course, reducing the speed of project implementation. And at the end, what was good solution for Croatia and maybe for some other countries, our idea was to develop a regional fund for energy efficiency, which will be funded half by municipality or county and half by government. Systematization of the jobs, which means that we need to have exactly defined working or job positions in cities and counties, which would be targeted for energy efficiency, strict legislation enforcement. You know, in Croatia we have laws, but sometimes laws are not controlled in the proper way. And finally, transparency. Especially transparency to residential sector is very important. If you would like to encourage those 30% of buildings or people to invest something, you need to pay a lot on education, and of course you need to have transparency. And I think that by this approach we can eliminate all barriers. Finally, we can conclude that energy efficiency is important driver, especially in the context of energy transition. Buildings are very important because buildings are complex from all sides, political, economical, and all other things that I have stressed out. Croatian experience is a good one. These projects and our results are promising, and the reason and the proof for that is that still a Croatian government is running, but not formally project, but we are running all activities that we have been set while we had the project. Critical barriers from my point of view are lack of educated staff. That is something which is important, which means human resources, and also development of efficient investment tools. We all know that ESCO projects in buildings are very hard to establish because of a lot of various things that are affecting. So no matter that you have funds, we need to further develop better ESCO principles. And finally, one important feature at the end is also efficient monitoring of those refurbished buildings, because we need to example of good practice to seed this good practice, and finally, at the end of the day, to be able to have a lot of buildings that are renovated or refurbished. Thank you for your kind attention.
Professor Sandro, thank you for this very valuable and fascinating presentation. And our next speaker is Professor Agis Papadopoulos. He is since 1998 a professor for energy systems at Department of Mechanical Engineering of Aristotle University of Selanik, Greece, and since 2013 Director of Process Equipment Design Laboratory. His research interests lie in field of energy conservation and renewable energy resources, energy and environmental design of buildings, and energy and environmental economics and politics. He has coordinated more than 65 national and international research projects, and he has published more than 450 papers in peer-reviewed journals and conference proceedings. He is editor-in-chief of International Journal of Sustainable Energy, associate editor of Energy and Buildings. He is since 2015 visiting professor at Technical University of Hamburg, Germany. And since August 2019, he is the chairman of board of EYATH, Selanik, water supply and sewage company listed at Athens Stock Exchange. and he is going to make his presentation, Resilient Buildings and Eco-Design, a path towards sustainability. Here is your stage, Professor.
Thank you, dear Ümit. Ladies and gentlemen, it's with great pleasure that I'm today with you here at the ZeroBuild Summit, and I would really like to thank the organizers and in particular the good colleague and friend, Professor Ümit Ünver, for inviting me. So I would like to share with you in the next 15 minutes or so a few thoughts about how we proceed with sustainable buildings, how we integrate them in a resilient urban environment, and this includes the infrastructure, and with a bit of luck present two examples. Now, I guess you remember last summer we had the heat dome, which troubled Turkey and Greece with huge wildfires, an extreme heat wave. Unfortunately, people lost their lives, but this also put a huge strain on the electricity system of the countries. We had the COVID pandemic in the last few years, which puts also a strain on, for example, the water and sewage infrastructure. And we have, of course, let's say, the energy crisis, which we are experiencing. If you can remember how cheap gas was 14 months ago, it can really be very worrying what the effects of the energy crisis for the next 3 or 4 years in the economy will be. So sometimes I believe that it is really unfortunate that we have a short memory. We had the energy crisis in the 70s, and we didn't learn much out of it. Okay, we improved our buildings, and this is important, but we forgot that there can be energy crisis. Now, even if the energy crisis subsides, let's say, in this year, after a few months, energy will become more expensive over the coming decades. It has to become more expensive if we want to make the energy transition, and it will become more expensive because it's a commodity in short supply. And you can see some prediction from the Fraunhofer Institute in Germany that with a bit of luck, in 10 or 15 years' time, we will be paying twice the price on average for electricity. In order to manage to have a growing economy, we have therefore to be more efficient. There is no other way around. You have heard many data. Building sector is hugely important for the economy, for energy, for the environment. 40% of energy consumption is not bad. If we want to achieve the goals of 2030 and 50, there's a lot of work that needs to be done. To be fair, since the 70s and the oil crisis, the building sector has made the biggest advance compared to transport and compared to industry. If you think of a typical building of the 1970s, it used 300 kilowatt hours per square meter a year. A typical nearly zero energy building today may need perhaps 40, 50, 60, something like that. So it's 6 times less. And this is a huge success. This has been done, and this is possible, and we can make even better buildings because there are lots of tools which were not there 2 decades ago. Super insulating materials, smart glazings, advanced heating, ventilation, air conditioning systems, magnificent building automation controls. You've heard a nice presentation before the break. Obviously renewable systems and also integrated facades. One of the good things about such a big fair like the YILMAZ fair is that you can see many of those systems in reality. But the problem is we have improved the performance of the new buildings, but we have a very old and big building stock in Europe. And this is why the average consumption, despite the progress made, is still quite high. I didn't find the value for Turkey, but on average in the European Union, you still need 200 kilowatt hours per square meter of building. Out of those, about 130 go for heating, which is an awful lot of energy. And if one sees the latest scenario for how this will develop in the next few years, even for very optimistic scenario that all new buildings will be zero energy or nearly zero energy, we will not have an improvement of more than, let's say, 2% on average a year in energy efficiency. So we have to address the issue of the existing buildings. At the same time, we have to improve the resilience of our buildings. Pandemics happen once every century, perhaps, but heat waves happen more and more frequently. We have 3 to 5 heat waves in Turkey and in Greece each summer with higher temperatures and with longer duration. So the buildings have to be able to cope with that. You have earthquakes, you have every possible sort of hazards, and the buildings have to be resilient. They have to be able to recover from a shock in a very short time and keep on working, having lighting, heating, ventilation, and so on and so forth. In other words, it's not enough to say that we were going to organize internally our building with heat pumps, insulation, glazings, whatever. We have to have on-site power supply, ideally from renewables, and this has to be coupled with the grid, both ways. And if you have an electricity market that is charging on hourly or half-hourly basis, which the target model foresees, then it's also a matter of economics to be able to utilize energy in a very flexible way. Hence, even the best energy building, unless it's absolutely autonomous on some small island, cannot be resilient and cannot also be efficient if it is not integrated with the infrastructure. And there is the technology. We have smart meters, sensors, responsive HVAC systems, we have everything. And our utilities, they utilize SCADA systems, smart grids, BIM. So in reality, when it comes to resilience, it's about strategies, processes, and practices on the one hand of the utilities, electricity supply, water supply, natural gas supply. On the other hand, how those policies and strategies are linked in a technical level with the building's behavior. A good example, you know it, most of you probably, is the temporal dimension. If we utilize storage technologies, we can shave the loads, the peaks, and this is immensely important, let's say, for the electrical system during a heat wave, but it's also immensely important to reduce the energy costs of a hotel or of an office building, or we can shift the loads, or we can fill the valleys. 3 different strategies. You can have any one of those 3 if your building is smart enough. Now, as I said, thanks to the technological advance, there is lots of data. The problem is, sometimes we have lots of data, but not enough information. Because if you don't filter the data, if you don't correlate them with the physical behavior of a building, and if you don't eliminate uncertainties, mistakes, and errors, you may end up with gigabytes of data, and you still will not be able to understand why your air conditioning system is not working properly. But we have to be able to utilize those data and to communicate them between the utility and the building. We must become able to aggregate data, but also to disaggregate ones, because 90% of our buildings do not have smart meters. So we have to rely on the data provided by the electricity supplier, who in the best of situations provide, let's say, data every hour or every 15 minutes, disaggregate them to a cluster of buildings and try to understand how the buildings operate, and the other way around. We had pandemics, earthquakes, heat waves. All this provides a very fertile ground to promote technologies to make use of this data more available, and this has to be done in an open access platform so that the municipality, utility can see how things run and how it can intervene. This is, by the way, the topic of a project we are currently running, and where we'll have BIM platforms in 5 cities, so I think this will be of interest. Hopefully next year we can show some results.
We hope.
But resilience has to be quantified, and the potential of buildings to adapt has to be quantified. So 1.5, 2 years ago, the European Commission issued a technical guideline. It's not a directive, it's still a technical guide. It's not a directive, not a guideline. How one can assess the smart readiness of building. So if we have a look at this exhibition hall, there's one question, how smart it is, and another question, how ready is it to become smart? And this guide is an interesting approach. Sorry. An interesting approach. It breaks down the building into its main operations: heating, cooling, mechanical operations, lighting, and so on and so forth. And it gives scores that help assess a building and its smart readiness. And this is a very useful approach because we have to be able to evaluate and to improve our existing buildings. Otherwise, we can have wonderful new buildings, as many as we like, but the rate of progress will be small. Oops, sorry. Two examples. I still have a few minutes' time. This is an office building in Athens. It was a new building constructed in 2005-06. My laboratory participated in the energy design. It is what we would call a low-energy building. It has concentrated solar thermal collectors, flat-plate solar collectors, geothermal energy, solar absorption, cooling, and photovoltaics. Everything. And with a bit of luck, it covers 70% of its demand from renewable energies. It also has some small storage so that you can survive a few days without decent weather, without additional energy. I think it was a very state-of-the-art low-energy building for the decade of the 2000s, especially since it was it has nothing to do with bioclimatic architecture, so it's a very typical silly office building, if I may say so, in an architectural way. But this was how it was built in the city of Athens. So the question is this a sustainable and resilient building? And to be honest, with today's standards, I would say no. It's a very energy efficient building, but there are still a few things more towards sustainability and resilience. Let me show you an example from Rotterdam, from the Netherlands. This not particularly thrilling looking building was an office building from the 1940s. Immediately after the Second World War, Rotterdam was razed to the ground by the German Luftwaffe in the 1940s, so they built this. 3 years ago, it was refurbished from the scratch. Only the load-bearing structure remained in order to be able to achieve climate adaptation and mitigation goals. So the energy efficiency is so good that it needs 2/3 less energy than a typical average Netherlands office building, which is quite interesting for a building that was constructed in the 40s. Now, they were using triple glazing windows. I'm not really sure it makes sense for Turkey or Greece, but for the Netherlands it does make sense, to be honest. They used an atrium and transparent facades to achieve good lighting, because lighting is hugely important for the well-being and also to reduce electricity consumption, also to reduce air conditioning loads in summer, by the way. They installed a highly efficient HVAC system, which is controlled by very smart automation and control, so Class A according to EN 15232. And now come the sustainability points. They use an aquifer thermal energy storage, so they utilize the water in the ground. Rotterdam is really built on the sea in reality, so that they can have 100% almost of the cooling requirements by heat exchangers, and approximately 50–60% of the heating, which is done conventional, the other comes also from geothermal energy, is being drawn from the district heating system of the city. So the CO2 reduction was amazing. Also, the resilience, the increase in resilience, because you have a source that depends much less on electricity. Finally, they have a green roof, which is very nice to reduce the cooling loads, though this is not the main problem in Rotterdam, but it is very useful in absorbing rainwater so that it acts as a buffer so that you don't flood the sewerage system directly, which can be an issue if you are in the Netherlands. In our regions, it would be very interesting in order to reduce cooling loads. Admittedly, we have to have a look at the water balance, but that's another story. So you see, how much technology has progressed, let's say, within 10 years in reality, and low energy efficiency building of the zeros and the sustainable resilient building of the tens. They may have the similar energy consumption, but they are worlds apart. Concluding thoughts, 60 seconds, Ümit.
Okay.
We have to integrate the architectural design, the engineering system, mechanical and electrical, and the operation of the building. To be honest, I have to make the point, it hurts me a lot. I'm a mechanical engineer by profession, but 50% of the building sustainability is a work of the architect. We come after that. Sorry about that. We need to achieve redundancy and storage by means of conventional and renewable energy supply. Both ways. We cannot have electric vehicles if we don't have buildings that can charge them and that can utilize electricity supply at the cheapest hours. And we have to achieve flexibility. And all this has to be possible in the least possible construction cost, of course, because money is not exactly abundant, and in a way that in which it can be financeable for the users. Because at the end of the day, we want to have buildings that are not only sustainable and resilient, but that are affordable for normal people who go to work, live, and have some leisure in this built environment. Thank you very much for your attention.
Thank you very much. Well, dear audience, we have a couple of minutes. I know we have lots of questions to ask these professors, but we have no much time, unfortunately, because of this. I want to ask them questions. One of the questions will go to two professors, and the other question will go to Mrs. Yilmaz. And for keeping the time as short as we can possible, would you please, professors, from the first Agis, Professor Agis to here, would you please share us your what in your bag about this project in energy efficiency in buildings as rule of thumbs? What would you suggest to Turkey, because Turkey is at the beginning of his history in the energy efficiency in buildings? What do you recommend to us?
I think we have always to keep in mind that we have to follow the golden rule of improving efficiency in buildings. Pay attention to the building envelope, insulation, glazings, natural ventilation, because in our climate we can utilize it. Then comes the time for heating, ventilation, air conditioning systems, which have to be efficient and appropriately dimensioned. And all this has to be integrated ideally with a state-of-the-art automation control system. It's only after that that it makes sense to speak of renewable energies. It doesn't make sense to have a building full with photovoltaics if the windows are leaking and if the roof is uninsulated. It's energy madness. And this is a package that can also be easier financed from banks, for example, than if you have independent interventions which are less cost-effective and are therefore more difficult to finance. So one has to stick with this rule, and there are no one-size-fits-all solution. You need to have a good engineering team that provides a good solution to each specific building, and then you can work with that.
Thank you very much. First, be careful about the passive systems and take good care of active systems and make a good engineering team.
Yeah.
Okay, so Professor Sandro, would you please?
Thank you. I would follow up with Agis' words. I will not repeat what he already stressed out, but I would like also to stress out this other aspect, which is very important. When I was on this position of deputy minister, the big problem was with financial tools. So no matter that we have technology that is ready for implementation, one of the most important issues is also, do we have good financial tools that are developed to fit all needs? Because for banks, they would like to give the money to support the projects, but the problem was this payback time, because everything is nice on the paper. You can basically manipulate energy efficiency savings on the paper, just moving one factor to another. But the reality is, what are the true energy savings? What are the funds that are being saved? Which is, of course, critical tomorrow if you want to have healthy payback time and if you want to get funds from financial groups. Second issue is also what is, from my point of view, critical, and what Turkey could also do is to strengthen collaboration between all engineering disciplines. Agis already stressed out one truth, that 50% of the building is responsibility of architects. But my field experience is that sometimes there are fights between mechanical engineers, between architects, and I think that this should be organized from higher level, you know, in order to have smooth operation, because nowadays we are not able to reach nearly zero energy buildings or zero energy buildings without close cooperation between all engineering disciplines. And at the end, I would also like to emphasize that since I work at University Agis also, critical feature is to develop new study programs which are more oriented on multidisciplinary approach, you know, because we have now engineers who are just dealing with pure mechanical engineering, but also we need to have engineers which would have like wide knowledge, so that tomorrow they can easily communicate with specialized fields. That is important from my point of view.
I see. Thank you very much. Professor Sandro says that if you have money, then you can save money. This is the first rule. And the second one, he said, team is very important, and for constructing those teams, we have to set up an education program and for multidisciplinary teams. And the last question goes to Mrs. Yilmaz, and you have told us about well buildings. In Turkey, we have not faced with green buildings at the moment, and you are talking about well buildings. Is there any barriers between the situation we are facing here and the well buildings?
Actually, I think in Turkey, WELL certification or the healthy buildings becomes a little bit of luxury, and we should concurrently build green, sustainable, energy efficient, and healthy buildings. And also, I'm agreeing my colleagues, Mr. Agis and Mr. Sandro, because in, for example, LEED certification or other green building certification systems, we like to design all together. So we do have the state that integrated building systems. So we should be all designing together, all the mechanical, electrical, plumbing, all consultants, architects. So architects, we should be the leader of the project, but everybody has to design all together. So the systems and the new building technologies requires this now. So not the architect becomes the main leader. So everybody has to design all together.
Be a part of this.
Be a part
Yes,
of it.
Thank you.
Yeah, of course, the architect should be always the leader, because that's the design process. But still, we should be all work together.
Thank you. Thank you so much. Now, this is the end of our session, dear audience. I thank my guests to participate in this session. Thank you very much.
Thank you.
Değerli izleyicilerimiz, az sonra Bremart konferansı olacak burada. 15 dakika sonra sizleri tekrar aramızda görmeyi diliyoruz. Çok teşekkürler.